Individual. All right. Yay, it started recording. So everyone get your homework out.
What homework? JK. JK, kids.
Kids? Really, John? Mr. Walking in. Oh, please don't disturb me. I have to make an origami frog and you're calling anyone else a kid.
I forgot it in my other folder.
Once again, thank you for making my point.
Have you ever seen that video of that guy who yells at trains and trucks?
What?
Have you ever recorded?
For the exact same reasons it always records?
Have you ever seen that video of the guy?
Hold on. I'm trying to... There we go. Alright, homework out, question up, read it, come up with an answer.
Arnold Schwarzenegger.
Homework?
I know how to do it. Arnold Strongman sues ball pool.
Thanks, Joe.
I know about the people who live there.
It's almost like it's up on the computer being recorded.
Oh, so it is re-recording.
It records whatever's on the computer.
Oh.
I was recording you saying, oh.
Got it? Okay, focus. Focus.
That's too hard.
Focus. Read.
I will say hi later.
I read.
Actually, you know what? Actually, this isn't the one I wanted you to do. Hold on. To quote John, Chick-hey.
What's the answer? Are you pulling, bro?
We'll come back to that.
Are you pulling? I'm going with you.
Hey, Mr. Bush, may I get my homework?
This is the one I want you to do.
I think you forgot something.
What's up?
May I go get my homework done?
It's from a YouTube video of a guy yelling.
What? Just ice. It has very little friction. Hence why it's so easy to step onto it, not go anywhere, and just slide and fall on your butt. I don't have personal experience with this at all. Raise your hand if you say the answer is A. Or there is no Whoops!
Wow.
Talk it over with your table. Actually, screw it. Go straight to group.
Who should I talk to?
Just my squirrel. Wow, your voice got very, very high.
Guess what? I can just talk to nobody but myself.
Fine.
What's the dumb?
Just leave your homework there.
Hey, said hi.
Okay, you just have to.
We said in the hallway.
I checked your guys' papers. That's what I thought. I'm just making sure. Dude, apparently I'm having to do it. You want to stop?
Hey, may I go get my locker?
And when I finish these, I'll be done.
No, you're gonna put them where I want you to.
Put the bag in.
No, I got it.
Wait, can I go get mine? It's in my locker. I told you.
Get me at it.
Oh, alright.
And look, put away the directions.
No, I need to do it.
You don't.
I do. I got another pair.
Do I have to light it on fire?
Do it. Yeah.
I have it.
Alright, listen up.
Oh, sorry, group.
Up here. Group 1, do you have an answer?
Yeah.
Yeah.
Kish has it.
You're not in group 1?
For the bottom one, they both come together at equal. They both meet in the middle.
Okay, group 2 has apparently been disbanded. Group 3? Wow, that's kind of bad.
That's easy to say.
Group 4?
Okay, well, we said that the guy fully is going to pull the girl onto her butt and she's going to fall and he's going to fall. They're not going to
Painter, what you gonna do?
He admits it.
By the way, I hope you guys were careful about what you were talking about, because you realize I can now hear every word you said, right?
I was locked out.
Are we passing
Let's have a freestyle Friday today.
Alright, one with their back to that wall, one in this chair.
Do we have a rope?
No, Matt.
No, I went and stole a chair from another teacher, but didn't have a rope. Because, as you know, I'm exceedingly stupid.
And maybe it was a seizure.
Wait, why are you stupid? I missed that.
It comes from years of dealing with teenagers.
Maybe he's getting hallucinations along with this.
Alright, back a little bit further. Now, this isn't perfect because there's still some friction, and that chair is worse than this one, so that one's going to roll a little bit less.
So we'll get a better
Okay?
chair.
They're not gonna move.
Just pull on the...
Oh, okay.
Alright, now here's what I want you to do. Feet up. Now, on the chair or under your butt or whatever you got to do. Now, both of you pull on the rope. Okay, they kind of wound up in the middle, right? Minus some slight falling. Alright, so here's what you're going to do. Danielle,
Yeah.
I need you to you pull on the rope. You just need to hold on.
So I don't fall into this chair is not moving right.
Not like that. You don't pull like that. You pull back.
This demo fails. Alright, fine.
I told you should have used guys instead of girls.
Yeah, that's going to solve it. It's not the chairs at all. Alright, we'll try this later with the roller skates. I couldn't get the roller skates today because the closet those are in is locked and I don't have a key.
They probably won't fit you.
Alright, so,
West side.
hey, no, Matthew. Just for that, you just volunteered. So, yes, to lick the Van de Graaff. What I need you to do is to take this chair, or that chair, and this bottle back to Miss Deerfield, doors down on your left. Thank you.
Why the water bottle?
Because she left it in here and she needs it. And I said, yeah, she's doing the minute to win it stuff with her kids that we already did. Alright, so, the correct answer is it should be the exact same. They should go 3 meters.
Exactly.
Okay, and we'll talk about why that is here a little bit more in a bit. Let's talk about your homework. Alright. First of all, I'm going to be slick, and let's see if I can make this work. I think this is in part.
have asked people.
You suck, Joel. Back to your seat, by the way.
No, Mr. Bush, I need a partner.
Well, that just creeped me out a little bit. Alright.
Wizard of Oz.
Yeah. You won't know that.
Now, for once again, I am exceedingly stupid.
I guarantee Annie's gonna be out of this entire video.
Oh my gosh, who sprayed something? Burning my nose here.
My nose.
Okay then. Thank you, Joel. Alright, let's see, we are missing a lot of people. Let's see. 4, 5, 6, 7.
I know.
Alright. So, here we go. Number 1.
7 people.
Your force diagram for block A should look something like this.
I wanted to do that so bad. Oh my god.
Got it.
Mr. Bush,
Hmm.
where you didn't notice you were left-handed?
I didn't notice that either. I didn't know.
You know, it seems like every single period, every single day, someone new notices I'm left-handed and somehow misses everyone else pointing out that I'm left-handed.
Is that force friction or force tension on the
Force friction.
Okay.
You know, they say that people with left hand usually have good handwriting.
Yeah, well, that's why.
No, that's a
That's alright, I'm a left, yep.
Actually, funny story, I used to be ambidextrous.
I am ambidextrous.
But when I went to school in Ohio, in elementary school, the teacher got annoyed that when we got sick of writing with one hand, I'd switch to the other one and keep writing. And my handwriting was different depending on the hand I used, so they made me pick a hand. And a lot of people think I should be right-handed, but because I was slightly rebellious, I picked left because no one else was left.
I do the same thing.
Slightly rebellious.
That was my big rebellion. That was my huge rebellion. Writing with my left hand instead of my right. I am a rebel. You should get like a leather jacket and a motorcycle.
They just rolled out.
The force of block
Facebook.
Oh, I'm sorry, A.
Facebook.
The force of block A. What are you whispering Facebook about?
FB.
I hate you so much. Alright, so this one right here is actually the force of block A on block B. Now here's the interesting thing. Here's the interesting thing. Yes. Which part? This is the force, you can think of it still as force applied, but it's the applied force of block A pushing on block B. What? It could be a normal force. I mean, there's a lot of different ways you could phrase it. I'm not really picky on how you label it. But you should have it at equilibrium, so all the forces should be about equal. Now here's the interesting thing. For this little letter here, raise your hand if you say the answer to number 1 should be A. Raise your hand if it should be B.
I think I did.
Raise your hand if it should be C. The correct answer is C.
Oh, man.
And here's how you know. Let's apparently he's sensitive about blowing his nose in front of people. Alright, let's see, who haven't I picked on today? Alright, let's say we take Carly. And we replace these blocks with semis. And we duct tape Carly to the front of one of the semis. And drive that semi into the back of the second one and start pushing that semi along. Now Carly's got some sort of special suit that keeps her from being Carly paced. Okay? I know you got a big schnoz, but come on, man. Alright. What's Carly going to feel? Can she feel, oh, this other semi is obviously crushing me more than this other one I'm smashed up between? Can she tell the difference between which semi is pushing harder? She's just in agony. Okay, but she feels both semis pushing the same. Let me ask you this as well. Let's say I take this marker and this remote. And if I push the marker or the remote along with my marker, what do you notice about the marker and remote? Do they stay together?
Yeah.
What would it mean if this marker pushed harder on the remote than the remote pushed back on the marker? Then the remote should go flying forward. And does that happen?
Yeah. No, that would happen, but it can't happen.
Really?
You can't push that hard and the one will fly.
While still moving the marker.
Oh, no.
Yeah.
No.
I can hit it, yes.
Yeah.
That's different. I'm saying, what about pushing it along? If I'm still pushing it, no matter how hard I push that marker, unless I stop the marker, but that's not an indication of a larger force, that's an indication of inertia.
Okay.
Right? I'm pushing this remote along, and when I stop this marker, this remote still has the inertia I gave it, and it continues along. That's not all of a sudden this marker just reaches out and slaps the remote. Okay? So the force has to be the same. Let's talk about number 2. Guess what? Your force diagrams are exactly the same. Raise your hand if you say the answer is A. Raise your hand if you say the answer is B. Raise your hand if you say the answer is C. Guess what the answer is? C.
So smart.
Let's talk about number 2.
What if you see since they're all equilibrium problems?
Well, let's talk. Well, okay, so maybe it's an equilibrium thing. By the way, the answer to number 3.
See?
Well, we're getting there because this is now constant acceleration. So let's talk about it. All right. So which problem am I even on?
Is that a girl?
2.
Somehow I'm on problem 8. Whatever. We'll go with it. All right. So problem 8. Skipping ahead. Whatever. All right. We're not at equilibrium. So let's see what our force diagram is going to look like.
Yeah, I'm pretty sure I did this wrong.
For object A,
Oh, no, I know it's wrong.
we have a tension this way. We have a normal force. And we have a force of gravity. Maybe we have a little bit of friction.
You said this is for 8?
What?
You said this is for 8 or 7?
8.
8.
I think it's that right.
should be alone. Much like all the other animals at the zoo. Alright.
They have relatives at the zoo. You never see an animal by itself. Yes, you would.
They do
Which
all
one?
the time.
No, the tigers have 2 tigers.
I thought a polar bear lives by itself in the water.
We have many weird debates in here.
What about
Next
whales?
up, which is better, Campbell's or Progressive? Alright.
Wait, whales have the whales.
The correct answer is canned soup sucks. Alright.
That was terrible. That was a terrible joke.
No, correct answer. No.
I'm sorry, they can't all be.
Yeah, correct
Alright.
answer is ramen. I love chicken noodle soup. Possibility.
Chicken noodle soup, the worst soup of all time.
Are you
Disgusting.
kidding yourself?
Alright, what's our answer? Raise your hand if you say it's A.
Oh, what did I say?
Raise your hand if you say it's B. Raise your hand if you say it's C. The answer is C. Not at equilibrium, but the answer's still C. Because let me ask you, if I take two things, let me come back here and grab two force gauges. And if I hook them up, so they are connected by tension, if they're connected by hooks, and if I pull this other force gauge along, what happens to the one I'm not actually touching?
Still comes along.
It goes along the same as if I was pulling it. So guess what? If two objects are connected and they're not flying away from each other, or even if they are, what can we say about the force between them? Always give me a thing. It's almost like we had a law
Oh God.
by a guy by the name of what was
Cameron
his name?
Newton. Oh,
Cameron? Almost like we had a law by a guy by the name of Newton. I think it was his third law that says for every action there's an equal and opposite reaction.
That was Cam Newton.
Cam Newton up the Carolina
I'm
Panthers.
surprised it wasn't Tebow. I mean, he does everything else fantastic, right? So.
Except for run.
Tebow so much.
Aaron
All right.
Rodgers. No, he ran pretty good.
Great question. Eight would be. As far as the force diagrams are concerned, no. Hey, by the way, what do you think the letter answer for number 3 is going to be? What do you think it's going to be for 4? What do you think it's going to be for 5? What are we noticing here?
A pattern.
Every answer is C.
I'm trying to tell you that.
Okay? Now, why doesn't mass matter? And here's the very important thing. Go back to that problem we had where we had the 7-kilogram mass dangling by a cord, and then we had a cord down from that one, and we had the 4-kilogram mass. Remember that one? That I think we went over on Wednesday. What did we do to figure out the tension on that top cord? We said if we cut it, both of those drop, right? So didn't we say that situation or one cable with an 11-kilogram mass is the same? Right? It doesn't really make a difference whether you have a 7 and then a 4 attached to it, or you just have one 11-kilogram mass. As far as that string is concerned, they're the same. So whenever you have two objects connected, they're attached, you can treat it like one object. So like say for number, which one is this? Number 9, you were saying they have a different mass, right? These situations are going to be different, but the force diagrams are going to be the same, because we can replace this whole thing with this. This situation and this situation are the same thing. They're not. But remember, these force diagrams are not quantitative. The idea is the same. Yeah, the tension, we don't know that these forces are the same. The acceleration of 9 is going to be a little bit different because you've got more mass, but the forces present are still going to be the same. It's just going to move a little bit slower.
Those arrows, so you're about to be on that.
Those are arrows, yes. Wow. Wow. Once again, that just happened. Let's move on, shall we?
Oh, pizza party.
Yes.
Okay, so the length of the force tension arrow and the force friction diagram
it does matter, because here's the thing. It says constant acceleration, right? So acceleration means non-equilibrium, which means your force of tension and your over here and your force of friction over here cannot be the same length. There must be an unequal force somewhere in order for there to be a net force, in order for there to be an acceleration.
Are you fun like this on the test, like where you just draw the force diagram and show that movie?
Probably not. Probably not. Now I will tell you, there's going to be and I'm telling you right now, and it's going up on YouTube. There's going to be a problem on the test that says something along the lines of, a horse is pulling a cart. The horse exerts a force of 500 newtons on the cart. What is the force the cart exerts on the horse?
Is the cart moving or is the cart actually moving?
It doesn't matter. It's still 500 newtons.
Oh, it's not negative. No.
Is it
It's
negative?
still it doesn't matter. It's still the same idea. If I punch the wall punches me back just as hard.
And because it hurts you more than it hurts the wall.
No, because I'm in fact the Hulk and I'm busting through that wall.
Oh, never mind.
So if I put punch back.
Alright.
What happens if you break through the wall?
Same thing.
It still punches back, but it's
Yeah, the difference is my force forward is larger than the normal force it can provide. So it's still the same force, but I still bust through.
Okay.
You a gangster.
Okay? Because what I wind up providing is the exact amount of force that the wall can provide, and then it breaks. When I stop providing the force. Yeah.
So that's why A is always going to be the same for B for the force.
Yes. Yes. Because if they weren't, then one of these objects should be shooting ahead of the other, and they're not. What you can think of is this. Even though this whole situation is at non-equilibrium, this point right here is at equilibrium. Those two objects are in equilibrium with each other. The system, however, is not. Okay? All right, moving on. Oh, I was going to show you a YouTube video.
Are they video people going to see this?
They will.
A video of the
You know what I just realized?
I got to see if I can find it. What's up?
The two demos you just did, the play people aren't going to see it because it doesn't record this way.
I'm fully aware.
Okay.
They'll. I'm sorry that not everything's perfect. They'll live. Look at it this way.
Yeah, let's watch Twilight previews.
Oh God, no. I actually had a you know that form you have to fill out if you're taking a vacation? I actually had a student come yesterday going, oh, I forgot, I need you to sign this, saying that she had to take a vacation today because she had to go to the midnight showing of Twilight.
Did you sign it?
No.
You should have.
You should.
Which studio was it?
Yeah, we need
Don't worry about it.
We need names.
Was it a lady?
You hope so.
You would think the she pronoun would have been an indication.
Hey, you could have tried to trick me. Oh, this is the British guy here.
No, 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 it's not.
It's MIT. There's a difference.
Are you talking about that teacher that teaches us?
Yeah.
Oh, where is it? I found it earlier. Easy. I found it easy earlier.
Are you sure you found it on YouTube?
Monkey show?
Shoot. Here, let me track it down through here. Here we go.
Monkey and gun. That is how.
Is it or no?
All right, it's kind of similar to the one we did. You look boring. No problem. I'm here to help.
Picture of a line of a.
Thank you, Caption Man. Really? Really, Eric? All right. Yeah, shut up.
Do they have to be switching first? Like, say one person is stronger than the other person. Does it still work the same?
Yes, absolutely. Because here's the thing. Think about tug of war. Did we talk about tug of war yet?
No.
Okay. What is the one thing you need to win tug of war?
Friction.
What if you have to pick the ultimate tug of war team?
Grip.
What would you pick?
I picked the Hulk.
Big feet.
The
15
fattest
is the Hulk.
people possible.
The what?
The fattest people possible. That's it.
You would be on my team.
Exactly. Because here,
Horrible. That's horrible.
Kids, you're coming with me.
it's what it is. It's all it is. And here's why. As long as you can hold on to the rope, what Newton's third law is saying, as I'm still trying to find this other thing, maybe if I also include tricycle, that'll help.
Don't put a comma.
There we go. All right. So, assuming you can at least hold on to the rope, and don't think I missed that Tebow comment. All right. Assuming you can hold on to the rope, what Newton's third law is saying is let's say you get the world's strongest people over on the left side, or your right side, sorry.
And you get the
And I get the world's fattest people who sit on the rope on the right side. As long as they can hold onto that rope, those strongest people, let's say they can pull with 30,000 newtons of force. Guess what the fat people pull back with?
30,000.
30,000 newtons of force. That's what Newton's third law is saying.
So how do
If you pull, you're pulling against yourself. The whole point of a tug of war is see if you can actually think about it. Who wins a tug of war? It's the people that fall over, or the rope slips, or something like that. That's it. The people with the largest friction, aka big people, win every time. I guarantee I could take on not any two of you, but two of some of you in a tug of war.
Me and Kish.
Yeah.
Brittany, Danielle, I can take it, no problem. Kish and Jeremy, I can probably take.
What about me and Joe? Me and Danielle, you couldn't take.
Oh, God.
Well, that's just because you're too
You
big.
couldn't take me by myself.
All right. Tell you what. On a day we don't have much going on, I'll take that challenge later. I'll prove my point. Ow.
If I win, I get extra credit for
All right. Shh. Another demonstration of Newton's third law. They make them?
That's awesome. See, I'm gonna do that now.
I don't think I can use mine. That's not loud at all.
Can you imagine loading up 6 of those on the back of that?
But here's the idea, guys. Here's the idea. The fire extinguisher shoots whatever it is backwards, right? That wasn't fake at all. The fire extinguisher shoots whatever it is, the fire extinguishing material, backwards. CO2 or water, I mean, it depends on the type. No, it was fake. Shoots it backwards. The amount of force that it shoots that material backwards with pushes the tricycle forward. Same idea how rocket engines work, same principle about how jet engines work, all those kinds of things.
So is it true that if I take a fire extinguisher and point it on the ground, it will lift you up?
If you had enough fire extinguishers, absolutely.
What was you trying to say? Is that how jetpacks work?
That's the idea. The problem is a fire extinguisher, it's too heavy for the amount of force it puts out, so it's never going to work.
Okay.
It's self-defeating. Rocket engines are lighter and put out more energy, so that's how they can work.
They're real?
Jetpacks?
Yeah.
Yeah. I mean, they only work for like 3-4 minutes at a time, so they can't carry much fuel, but yeah, they exist.
I just seen
They're awesome.
All right. Oh, I didn't mean to do that.
I'm gonna crush some crab pizza right now.
All right.
Guys,
Come on, guys.
It's a classical.
Thank you.
You sound like a dying animal.
He looks like one too. All right.
I almost said something about yourself.
Let's not. Think of the YouTube. All right, here we go.
This is gonna be a problem when I'm at home, cause I can't tilt it like you can. So,
It's almost like you write on pieces of paper that are easily tiltable. I just can't tilt the projector.
bet.
Really, Joel? I can't do it. I can't take you guys anywhere. We have a ramp problem. I am telling you, there is no friction.
So it's a glacier.
What I want you to figure out, what is the mass of that box hanging off the end?
30.
It's motionless.
30. It's 30 newtons.
That would be wrong. Try figuring it out.
3 newtons. Oh God, no. Oh, there's gotta be trig.
300.
Guys, let's instead of just writing out or yelling out random crap, how about we actually, I don't know, decide if we're at equilibrium, draw out a force diagram, break up the angles into components. Yeah. I don't know, all those steps we're supposed to follow for a force problem.
I wouldn't know how to do that.
You're not gonna pass this class, but
Your calculators do in fact need to be in degrees.
I was sure to change it back, and then I went back and it was wrong.
We don't even use trig in math yet, so it really doesn't matter, does it?
Pre-calc you will.
Oh yeah.
Eventually, yes.
Okay.
You'll get to radians and you'll have so much fun with the unit circle.
this is sarcastic.
Wait, did you say you hate number theory?
I do hate number theory.
Okay. Because I asked Ms. Goss about it. She says she loves number theory.
She would. She majored in math.
Yeah.
I only got a minor in math because, well, you kind of have to if you're majoring in physics because you have to take so many math courses. I think the number of math courses I was required to take left me like 2 classes short of a minor, so you just might as well pick it up at that point. Actually, I don't think I technically have a minor because I never had the university say I have a minor. I should probably do that sometime.
Probably. Is it true that like mathematicians hate infinity, but physics people love it?
No. Mathematicians just hate them stuff.
So Ms. Goss hates herself?
Problem, do it.
How would you draw the is there a force diagram for the box too?
There's 2 boxes. Which one are you talking about?
Alright, so is there a force diagram for both boxes?
There would be, but you would have to draw them separately. For the first part, though, you only need to draw a force diagram for the box on the ramp, the 30 kilograms. You're beyond help. I mean, well done. Okay. Are you at equilibrium?
No. Oh no. Am I at equilibrium yet?
That's step 1. Step 2, draw a force diagram. It'll be that dot with the lines indicating the direction and type of force.
Okay, yeah, I was going for like. Where's the midpoint?
What?
Which was?
You have to start and do the first you draw your dot, and then like there's all the
That turn, is this how you turn it? Turn like that, or you no, I didn't.
Well, you can't turn it Alright, tell you what, let's do force diagram part first.
I know gravity's going down.
Alright.
That's
You ready for this? This isn't the right marker.
Wait.
You could use that marker.
I could, but then the Oz people would be all confused and Annie would come to me crying and no, Megan would come to me angry.
Maybe they should just not make the poll and do the poll.
Alright.
I hear you.
That's the thing.
They have feelings, Scarlett.
Actors aren't real people.
They don't
All
have
right.
feelings, they're actors.
So,
That's what this
alright, we've got gravity, right? We're always gonna have gravity?
Yeah.
Gravity acts which way?
Down.
Alright, what else?
Normal force.
The normal force, which acts which way?
Up. To the side.
that's perpendicular.
Not parallel. Come on, man. Come on, man.
And which way, what other force do we have?
Tension.
We have a tension, we have a string, right? And that string's gonna pull which way? Up the ramp, right?
Up, right.
And that's a force of tension. Now, what's the trick we do before we break things up into components with this type of problem? We decide to say that, hey, up the ramp is our x, perpendicular to the ramp is our y. And so we are going to turn this whole bad mem jam.
Whoa. Bad man.
That did not require singing. No. Alright, now I'm just going to move, let's see, I'm going to move this whole thing over and up, why not? You'll be fine. Come on. Guys, come on, don't be silly. Alright, now, can we break something up into components? Absolutely, which one? Gravity. And do we happen to know what this angle is going to be? 30 degrees. By the way, do we know what the force of gravity is going to be?
On the top object, yes.
Well, on this object, which is all we care about so far, what's the mass?
It's 30.
30, and we multiply the mass by negative 10. And using our superior mental math skills, 30 times negative 10 is fantastic.
It's okay, Carl. I'm trying to help you out. You over here haven't seen it.
Alright. Do I have to fail you in playing nice with others and sharing the sandbox?
Oh. Guys, why do you share my sand?
Alright. Now, I'll let you in on a little hint. We don't care about the y direction in this problem. We just don't care. So can we find the x component?
Opposite over hypotenuse.
It's opposite over hypotenuse. So that's sine.
300. So 150.
So x does in fact equal 150. Now, think this through. Now, first of all, which direction is x pointing?
Left.
Left, which means this should be...
Negative.
Now think this through. Without writing the equations and stuff, we're still going to do that, but just for this problem, we're not. If our x component of gravity is negative 150, and we are at equilibrium, what does our tension have to be? 150. Okay, now let's go back and think about that box dangling over the side. What's our force diagram going to look like for that box? Agreed? Now ask yourself this. The tension in that string on the ramp is 150 newtons. What do you think our tension here is going to be? 150 newtons. It's the same string. Is there any reason why randomly halfway down it it's going to become more tense?
No.
No.
There's a ghost.
Yeah. Blame the ghosts.
Ninja.
Alright. So if our tension up is 150, what must our force of gravity down be?
Half. 300.
Now, we've always found the force of gravity by taking the mass and multiplying by negative 10. What do you suppose would happen if we had, say, the force of gravity? Well, we know the acceleration is negative 10. So how could we use that possibly, I don't know, to find mass? Divide it. If mass times acceleration equals force, then force divided by acceleration equals Mass, what's negative 150 divided by negative 10? 15 kilograms. That's it.
I told you it was flat.
Any more than that, that block slides up the ramp. Any less than that, that block falls down the ramp. Exactly. Questions? Alright, for your homework tonight. First of all, how's that problem set going? Everyone's finished the questions by now, right?
Yeah.
And we're fully entrenched in working on those problems?
Yeah.
Right?
Of course.
Just lie to me, guys.
Yeah.
We will.
Yeah, okay, fantastic.
You said lie to you, people were ahead.
Your homework tonight. 4 problems. This is the last time we're focusing on purely equilibrium.
Oh god.
2 are rams, 2 are not.
Can't just throw us into the diving pool like that. It got you kind of wood.
First of all, sure I could. And in fact, if I really wanted to, I could put you, give you concrete shoes. Second of all,
We have taught us how to swim.
yeah, I'm pretty sure we've spent, a week by now on equilibrium.
No, yesterday is when you threw us in the deep end.
Yeah, a little bit. You're all still alive and kicking. Little water loss. Alright, everyone say goodbye to the Alice people.
That's a legit progress. No, it's
I'm now thinking of Princess Bride. Have fun pillaging the castle. Or storming the castle. Alright, I'm done.